Hello students, welcome to the topic electrolysis part 2. Yesterday in the previous video we discussed about the part 1 and today we are discussing electrolysis part 2. Yesterday we had discussed about the concept of when an electrolysis is taking place, what will be deposited at cathode and what will be there at anode being formed. That is, when we are giving current to a particular cell due to the chemical reaction taking place, what type of the products are formed at cathode and anode. Yesterday when we were discussing about the electrodes which were themselves not participating in the reaction. That is, we were using inert electrode. So today we shall be discussing about the electrodes which are active electrodes which are going to participate in the reaction. So let's go to an example with an active electrode, that is electrolysis of copper sulfate. Electrolysis of copper sulfate, aqueous solution in presence of copper electrodes, in presence of copper solid electrodes. Okay. Usually in this type of an electrolysis, we use impure copper anode, impure copper as anode, because this method is used for the refining of copper metal. So in that case, how the reaction is used or how the cell is being used, how electrolysis is being used is what I am teaching you. That is, the impure copper is taken as the anode and the pure copper rod acts as cathode. Okay. Now let's check on the reactions taking place here. Since we have taken copper sulfate aqueous, we will be having the ions as Cu2 plus SO4 2 minus plus H plus OH minus. Okay. Now when we take the reaction at cathode, always remember that at cathode the sign is found to be negative, and here always what will take place? Reduction will take place. So since the sign of the cathode is negative, the positively charged species will come towards the cathode. That is, you will be having a reduction of copper to form copper solid with a reduction potential value of plus 0.34 volt. And similarly, we can have the approach of H plus. So this H plus reduction can also take place. We usually in the last class we discussed completely as water reduction itself, or you can even say that there is reduction of H plus is taking place, and as the reduction of H plus takes place with gain of electrons. So instead of writing H plus, we can write it as water reduction. 2 electrons reduces to form H2 plus 2 OH minus, and its reduction potential we have already seen as minus 0.83. So you can see easily here our rule that the reduction potential which is higher in value, only that reduction will take place at the cathode. So when we compare these two, we can see here the higher reduction potential is that of copper. So you can say that at cathode, copper is deposited. Clear? So you can say that copper is deposited at cathode in this reaction. Now let's move on to the concept of anode. So we are discussing about at anode what is going to take place. You already know that at anode the electrode is positively charged, and here always what will take place? oxidation has to take place. When we check on this case, we can see here that here we are going to have a sulfate ion concentration present. Sulfate ion is being present. When we consider the sulfate ion, we can see that this acts as an oxidizing agent. It is a better oxidizing agent and hence it oxidizes copper to copper 2 plus 2 electron. Instead of any other oxidation reaction taking place, that is not even the water is getting oxidized here, you can see that the oxidation takes place of the copper rod which itself is present there, and it is being converted into Cu2 plus 2 electrons. Okay, so as the system is going to proceed, you can see here that the anode electrode diminishes in size. Because what is happening? All the Cu2 plus ion is getting involved into the electrolyte. That is what is taking place here. So now in this case we can very specifically see that we have taken what type of an electrode? We have taken an impure copper electrode as anode. So what happened is that from the impure copper electrode, what is going to happen? The copper is converted to Cu2 plus, passing into electrolyte, and that impurity which is present there, the impurity present in the rod, that particular impurity is going to drop down at the bottom of the cathode. I am going to write it here. You can see here that what is going to happen. The impure copper electrode, copper is getting converted to Cu2 plus, passing into the electrolyte, and the impurity falls down to form anode mud. Clear? So I am going to tell you one more time. We are taking a new example where the copper sulfate electrolysis is taking place, but it is taking place in presence of the reactive electrodes. So when we take reactive electrodes, let's go step by step. At the first stage, the current is passed, the copper sulfate dissociates into copper 2 plus SO4 2 minus along with the water which is present there. The aqueous condition is water is present there. When we come to the cathode, at cathode reaction, if we check, we can see that at cathode we have got a negative sign. So there, and at cathode always reduction is going to take place. So since cathode is having a negative sign, the positively charged species moves on to cathode. Now we have got two types of reductions taking place here. We have got a reduction of copper, we have got a reduction of water also. In both the cases, you can see that the higher reduction potential value is for copper plus 0.34 volts. So that reduction takes place there and copper is getting deposited onto the cathode. Now when we come to the anode, we said that if you take simply a copper also, or if you take an impure copper rod, here I am taking an impure copper rod. Since I have taken impure copper rod, what we can see here is that the presence of sulfate ion. The sulfate ion present and is a good oxidizing agent. So it itself undergoing oxidation, what it does is that it oxidizes the copper reactive electrode which is present there. Now the copper which is present there is getting fastly oxidized into Cu2 plus 2 electrons. Now since in this particular example we took the anode as an impure rod, of course when copper is getting converted and being deposited onto cathode, the impurity is going to drop down from the anode rod and get collected at the bottom of the anode, and that is what is called as anode mud. So this is what is called as anode mud, and this method is quite popular in metallurgy, where it is used for the refining of the copper metal. Not only copper metal, in many different metals we can use this particular concept. Is it clear for you? Is it clear? Okay. Now, I want to ask another question to you. That is, if we are considering the case of a reactive electrode, suppose we are not having a reactive electrode, then at those situations, what is going to happen? At that situation, it is very easy to understand. That is, as far as cathode is considered, we don't have any change of reaction because the same reaction is going to repeat even when the electrode is not reactive. But when we come to the case of the anode, the situation is entirely different. In the anode, now the sulfate is not required to oxidize the copper because the rod itself is inert. It is not going to participate. So then at that time there is only two competitions taking place. The competition is between the sulfate oxidation and the water oxidation, and in that case the water oxidation takes place and hydrogen is liberated. So I would like you to note down that particular concept also. So I am going to change this to a condition where we are going to take a particular copper sulfate electrolysis in presence of inert electrode. So let's just change this thing. We have got only few things to change here. I am going to write here as a electrolysis of copper sulfate in presence of inert electrode. In presence of inert electrode. In presence of inert electrode is what we are going to see here. So in the case of inert electrode, I already told you that at cathode the same reaction is repeated. At cathode there will be no change. But when we come to the concept of anode, there definitely will be a change. So let's just look on to the case of the anode. So at anode, what is going to happen? At anode, since the anode is having a positive charge and oxidation only takes place here. Remember that I am talking about a condition where the electrode is inert. The electrode is platinum electrode, or it is an inert electrode which does not participate in the reaction. In that case, at the anode, what is going to take place here? You can see that we can have two possibilities of oxidation. Either the water is getting oxidized to half 2H2O gives O2 plus 4H plus 4 electron. So its reduction potential, we have learnt it in our last class that the reduction potential for this reaction is found to be minus 1.23 volt. Minus 1.23 volt is given. Okay. Similarly, you have got sulfate ion going for it. SO4 2 minus is undergoing oxidation to form S2. Thiocyanate ions S2O8 minus plus 2 electron is formed and its reduction potential is found to be minus 1.96 volt. Minus 1.96 volt. So when we come to the anode, there is a competition between the two types of oxidation. Only one will take place and we already know which one will take place. In this case, the oxidation will take place only for the one which is having a higher reduction value. So when you compare minus 1.23 and minus 1.96, in this two negative values which is a higher value, minus 1.23 volt. So this is what is going to happen. So when you are taking the electrolysis of copper sulfate in presence of inert electrode, you have got at anode liberation of oxygen gas. Liberation of oxygen gas is going to take place, and at cathode what is going to take place? At cathode you will be having a deposition of copper. So this cathode reaction is common whether you take an inert electrode or you take a reactive electrode. The electrode doesn't affect the reaction at cathode, but it is at anode that the reaction is affected. That is, if you are taking an inert electrode, then there is liberation of oxygen, but when you are taking an active electrode, sulfate ion being a good oxidizing agent, instead of undergoing self-oxidation, they make the copper rod to get oxidized as Cu2 plus 2 electrons. So when a reactive electrode is taken, that is how the reaction is taking place. But when you are taking a inert electrode, this is the way the reaction is going to take place. Clear? Okay, now we'll go for the next example. These are all parallel examples. The more examples you practice, the more you will be clear about it. Let's go for the electrolysis of an acidified water. We are going for the electrolysis of an acidified water. Next example. Electrolysis of acidified water. Acidified water. That is, we have taken water and added on sulfuric acid. A little of sulfuric acid is added. Okay, in this case, what is going to take place? So again, the same way, when we take such a reaction, when we come to the case of at cathode, at cathode you will be having negative value, and here always what will be taking place? Reduction will be taking place. Reduction will be taking place. Now in this case, when you take water, it is divided into H plus and OH minus ion. When you take sulfuric acid also, it is divided into H plus and SO4 2 minus ion. So that means the cation formation of H plus is the same here. So you can say that this is the reduction reaction that is going to take place here. What is the reduction reaction? The water is going to take up 2 electrons and you will be having the formation of oxygen gas plus 2 OH minus. You will getting the reaction as a gain of electrons, giving you hydrogen plus 2 OH minus. Sorry, wrote a wrong thing. That is, when we take 2 H2O plus 2 electron, we will be getting H2, 2 H2 plus 2 OH minus. 2H2 plus 2 OH minus is formed, and this is the gas formed here. So you can say that at cathode, that is liberation of hydrogen gas. This is the only reaction that will be taking place, because I said that already at the cathode the cation is attracted and the cation formed here is only H plus. Okay. Now we can move on to the concept of anode. When we are talking about the anode, because of the dissociation, we can have two types of reactions here. Two types of anion is being formed. What are the two types of the anions which is being formed here? That is, when you consider the case of at anode, you already know that there will be positive sign and there will be oxidation taking place here. So here you will be having two types of ions approaching here. One will be having the OH minus ions and the other one is SO4 2 minus. So now there will be a competition here, that which type of an oxidation has to take place. When we consider the oxidation of sulfate ion SO4 2 minus gets converted into S2OH 2 minus plus 4 electrons. It is going to liberate 4 electrons and its reduction potential is already given as what? Minus 1.96 volt. Similarly, you will be having the oxidation of water also. Water oxidizes to form water plus 2 electron gives, water is undergoing oxidation. So 2 water molecules gives O2 plus 4H plus 2 electron. 4 electron. Okay. Now this reduction potential is found to be here as a minus 1.23 volt. Minus 1.23 volt. So you can see here that which type of an oxidation is favored here. The oxidation which is favored is with one higher reduction potential. So you can write that at the anode, you will be having the liberation of oxygen gas. So this is how we are going to understand the electrolysis of a acidified water. When we talk about acidified water, we are adding little of sulfuric acid into this, and this is how the reaction takes place. The ions will be split at anode, they respectively, since anode is having a negative charge, since anode is having a positive charge, the negatively charged anions will be moving into it. The two reductions are written, that is reduction of sulfate as well as the reduction of oxidation of sulfate ions and oxidation of water is considered here. The water reaction is found to be having a higher reduction potential, so that is what is going to get oxidized here, and liberation of oxygen. At cathode, you have got only one type of ions being formed here, whether it is dilute H2SO4, whether it is water, you will be having only H plus cation forming. So it's only the water which is undergoing reduction there. So as the reduction takes place, on reduction you will be having hydrogen gas being liberated. So this is how the reaction takes place. But I would like you to write one thing here very clearly, that is, if the solution is taken as concentrated, that is, we are taking concentrated sulfuric acid electrolysis, then when we write here, you can see that at cathode you will still be having the liberation of hydrogen gas, but at anode this time the oxidation of sulfate is favored. Sulfate is favored. Clear? So please write it down that when we can change it from dilute sulfuric acid to a concentrated sulfuric acid, then at cathode there is no reaction changes taking place, you will be having hydrogen gas liberation. But at anode, where the oxidation has to take place, instead of oxygen gas liberation, you will be having the sulfate ions liberation. Okay. Clear? Now we can go for another example. When we take one or two more examples, it will be very, very clear for you. So let's take the examples here. Okay. Let's take the electrolysis of silver nitrate in presence of silver rod or silver electrode. So we are taking silver nitrate here, AgNO3 aqueous is taken, and in silver electrode. So we are taking silver electrode here. So let's check on here. At cathode, what is going to take place? At cathode, we can see here that there will be reduction of Ag++ electron to form Ag, and you will be having the reduction of water. Water being reduced to form, water is being reduced to form hydrogen gas plus 2OH minus. Reduction potential of silver is found to be, already would have by now learnt about it, plus 0.80 volt. And the reduction potential of the water undergoing reduction is found to be minus 0.83 volt. So which one is a higher value here? Very easy to understand. It is for the silver. So you can put a tick here, and you can understand that at cathode what is happening here? Silver is being deposited. Silver is being deposited. Okay. Now, when we take the concept of at anode, let's go and check it at anode what is going to take place. Okay, now at anode you can see that because it is a positively charged rod and only oxidation takes place, the ions which moves up to here will be the ion of NO3 minus and the ion of OH minus from water. Now here the NO3 minus is again a strong oxidizing agent. The strong oxidizing agent. So what it does is that it takes the silver from the rod and makes it undergo oxidation to form Ag++ electron. So you can see here that the anode silver rod continuously diminishes, whereas the cathode silver rod will be continuously being added on, or the thickness goes on increasing. So I hope that you are able to understand these types of examples. One more example for you, that will be the final example for the day. Let's take the electrolysis of copper bromide. Electrolysis of copper bromide in presence of inert electrodes. In presence of inert electrodes. So let's check on that electrolysis. Okay, copper bromide, aqueous, in presence of inert electrodes. Inert electrodes, we can use platinum. One of the examples of an inert electrode is platinum, which is very least reactive. Now let's check here. At anode, at cathode, what is going to take place? At cathode, the cathode is always having a negative charge. Here always reduction takes place. So what type of the ions will be coming here? You will be having the ions which is coming here as either Cu2 plus, which undergoes reduction to form Cu2 solid, and the reduction potential you already would have by now by hearted as plus 0.34 volt. Okay. Similarly, what is the other positive charge which has to come? You will be having the H plus coming up, which we consider as the reduction of water molecule. 2 electron, and the product formed here will be hydrogen plus 2 OH minus. You know that its reduction potential is found to be 0.83 volt, minus 0.83 volt. So here, which is a better, which is a higher reduction potential value, you will be having copper. So you can say that at cathode, what is going to take place? Copper is deposited. So here you can see that the copper has been deposited. Now we'll go for the case of at anode. What is going to take place here? Okay, fine. At anode, it is positively charged and only oxidation can take place. Okay, now the ions which is going to come here will be, one of the ions is going to come as OH minus. You know that in OH minus we will be considering as water undergoing oxidation to form half O2 plus H plus 2H plus 2 electron, and its reduction potential value is found to be minus 1.96 volt. Similarly, you will be having Br minus coming here. Br minus, that is going to get converted on oxidation as half Br2 plus an electrode, and its reduction potential value has been found out to be minus 1.08 volt. Okay students, tell me that which will be having a higher reduction potential value. Is it minus 1.96 or is it minus 1.08 volt? Higher value. The higher value will be minus 1.08 volt. So you can write it very easily that at anode what gas will be liberated? The bromine gas is being liberated at cathode. Clear? So I hope that these examples are clear for you. You can do more examples, practice from your textbook. Only remember that if an active electrode is there, you have to consider the reaction very clearly at the anode position. Cathode is usually not altered whether the electrode is reactive or not, but anode reaction definitely is altered considering whether the reaction is in presence of a reactive electrode or a inert electrode. So this much is clear for you. And in our next class, what you can already would have seen here, that we are having depositions and we have got getting liberations at anode and cathode. Now we'll decide that because these all processes are used in industry, we use this for industrial preparation of many types of the products. So when we are running an industry, we will be very particular about the cost price which is being invested there, what price we will be having for preparation of each type of component. So in the next class, we will be learning the important Faraday's laws of electrolysis, which teaches us that how much current is passed, how much amount of substance will be deposited, relations among them. That's Faraday's laws of electrolysis is what we are going to discuss in our next class. Thank you.